let's take a look at an example of a one sample t-test for paired data for a difference between means. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and the placebo was randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table displays data on the subjects' depression test scores. Higher scores show more symptoms of depression. Do the data provide convincing evidence at the 5% alpha level that caffeine withdrawal increased depression score on average for subjects like the ones in this experiment? So we've got two sets of information, but the information is coming from the same individual. So for instance, this table, subject 1, after they took the caffeine pill, they scored a 5. After they took the placebo, they scored a 16. So for a paired test, we're going to make the comparisons within this sample. So we need to figure out what the differences are for each subject, and we'll use those differences for our one sample t-test. I chose to do the placebo minus the caffeine. That way we're working with mostly positive numbers. So the differences for subject 1 was 16 minus 5 and 11. The difference for subject 2, 18, 1, 4, and so on and so forth. So now we can treat this information right here as one sample, and we will state our hypotheses and the parameters of interest. Our hypothesis is that the expected or the mean difference is equal to 0, which means that there is no difference between the scores when they take caffeine or when they take the placebo. But we're going to run the test in hopes to build evidence that the mean difference is greater than 0. We want to see if it's greater than 0 because that means the placebo depression scores are higher, which the placebo, remember, is a fake pill. So they're not actually getting caffeine, which means they're not getting the normal caffeine intake, which means if this score is higher, then the caffeine is reducing the depression score. So we want to see if there's evidence that the score is greater than 0, meaning the placebo results in higher depression scores. Next, we'll state the method of inference and check the conditions. This is called a paired t-test for a mean difference. The random condition is met because the researchers randomly assigned the treatments to the subjects. So remember, usually the random condition is we took a random sample, but there was no sampling done here. The randomization has to be met from an experiment showing that the treatments were randomly assigned to the individuals. And that was true in this case. And it's important for them to do this because we don't want everyone all the subjects take the placebo on the same day, just because there could be other factors influencing that specific 2-day period. So the randomization helps to reduce variation and helps to control for other variables that could be at work here. The 10% condition, we don't have to check because there was no sampling done without replacement. These were, remember, volunteers. So we'll check the large normal condition where we're going to have to look at a dot plot or histogram or a box plot of these differences here. So we'll open up the calculator and look at a box plot for these. I'll put the differences in list 1. Now the differences are in list 1. Let's take a look at a box plot here. So you can see the box plot, the median looks to be quite central in the IQR, and this tail is a little bit longer, but overall there's not strong skewness in this box plot. and there are no outliers, so we're safe to continue with T procedures. I've copied over the box plot from my calculator where I have the change in depression when it's placebo minus the caffeine. And even though the sample size is small, which means it's less than 30, there's no strong skewness or outliers, so we can proceed with T procedures. Remember, you actually have to show the graph when your sample size is less than 30. In the do section, we're actually going to conduct the test, but I want to show you how to do it on your calculator, or remind you how to do it on your calculator, and then we'll come back to the notes. To do the one sample t-test, or the paired t-test, on the calculator, we do stat, tests, and it's a one sample t-test. So there is the t-test right there. And I have the data listed in my calculator, so I'll use the data. The mean difference is 0 from our null hypothesis. We're using list 1, and we said the alternative was that it is greater than 0, greater than the null. So we'll calculate, and this will give me all the values that I need, which would be the test statistic of 3.53, p-value of 0.0027. This is the sample mean and the sample standard deviation. Our sample size is 11. Really, for full credit, all I have to do is take all of this information, transfer it into the do section of the problem, and you'll get full credit. So if you don't want to be refreshed on how to do it by hand, you can fast forward over the next parts. But I am going to copy over the mean and the standard deviation and then work it out by hand as well. Here's all the information from the calculator, and really, this is all that you need to proceed to the conclusion, but I just want to work it out by hand and remind you so you can fast forward over it. But you need to show the test statistic and say it's the test statistic 3.53, and the p-value was 0.0027, so this is what it should look like. To find the test statistic, we're just going to use the formula for a one sample t-test, where we have the mean minus the null divided by the standard error. So our test statistic, like you saw, was 3.53. Then we'll use TCDF to calculate the p-value. And this is a one-sided test. So we won't have to multiply our p-value by 2. And our p-value, we're looking for the values greater than 3.53, and we get 0.0027. So now we can draw our conclusion. With a small p-value, we have evidence against the null, which states that there is no difference. Since our p-value is less than our alpha level, we reject the null. We have convincing evidence that the caffeine withdrawal increases depression scores on average for subjects like the ones in this experiment. Just remember the important things: compare alpha with the p-value, say that you reject, and then we have convincing evidence for whatever the null is in context. Now, I do want you to note that they're drawing this conclusion about subjects like the ones in this experiment. There was no random sample taken, so they can't say this is true for the entire population, for everybody. We can only say it's true for people that were similar to the ones in this experiment, because we didn't take a random sample to draw inference about a larger population. We can only say it's true for people like this, because that's our scope of inference.